Here's another interval of convergence problem for what real values of x, that summation as n goes from 1 to infinity, e to the n, x minus 1 to the n, over 2 to the n times n converge, and give you reasons. So as usual, first do the ratio test to get the radius of convergence, and then we start solving the inequality to get the interval of convergence, and you have to check the endpoints. So we do the ratio test, a sub n plus 1 divided by a sub n. This is the setup, limit as n goes to infinity. Okay. We start simplifying e to n plus 1 divided by e to n, subtract the powers, the properties of exponents. So we get e on top. That's a constant, so I can pull it out in front over here. Similarly, x minus 1 to the n plus 1 divided by x minus 1 to the n. I'm trying to speak fast and messing up. You use properties of exponents, you subtract the powers, you have x minus 1 to the first power. That doesn't depend on n, so we can pull it out in front, but be sure to keep the absolute value. By the way, why did I not keep the absolute value on this e? What's the absolute value of e? E, remember, is 2.7 something. It's just e. That's why you can drop it there. Okay. And similarly, 2 to the n divided by 2 to the n plus 1, subtract the powers, you have 2 to the negative 1 power. So I can, again, pull that out in front as a half. Okay, now we take this limit as n goes to infinity. This is a rational function. The degrees are the same. Take the ratio of the leading coefficients. This is 1 over 1, which is 1. This is the limit. Okay, we set this limit less than 1. Again, if you came from the previous problem, it's because the ratio test says this power series converges when the result of this limit is less than 1. It absolutely converges, actually. Okay, now we start solving for this inequality. So you got to be good with your algebra, not that difficult, but multiply by 2 over e on both sides and then add 1. Okay. So that's what I did over here. Okay. This is what you would get. Now, we got to check the endpoints. Remember, again, if you came from the previous video, if not, this is the reminder that at the endpoints, the ratio test is inconclusive because that's exactly when the limit is equal to 1. The ratio test is inconclusive, so we got to check it ourselves. So we check endpoint 1 minus 2 over e. Okay, so we plug in 1 minus 2 over e into x right here. Okay, what's 1 minus 2 over e? Minus 1. That's just minus 2 over e. Okay, now the 2 to the n's would cancel, the e to the n's would cancel. So you're left with minus 1 to the n over n. This is just algebra here. Yeah, you got to be good with the algebra. So this is the alternating harmonic series, which we know converges. That should be a good enough justification, in my opinion. I don't know if this professor went over the alternate harmonic series, but I'm assuming he did. So this should be a good enough explanation. Okay. Now we check the other endpoint, 1 plus 2 over e. We plug that into x up here. You would start simplifying. So again, e to n divided by e to n, that will cancel. 2 to n divided by 2 to n, that will cancel, right? So you're left with 1 over n. What series is this? This is the harmonic series, which diverges, or a p series with p equals 1, which diverges. Okay, so what does that mean? That means our interval of convergence, it includes the lower endpoint, but does not include the upper endpoint. So we need to write our inequality as less than or equal to, on here, the lower end, but we keep the only less than on the upper end. Okay, you can also use interval notation if you want, but I decided to write it like this because I already had that over here, copy pasted. Okay, all right, so this is a example of one power series that converges at one of the endpoints but doesn't converge at the other endpoint. And again, this is pretty typical leveled in my opinion, no matter what school you go to. The only really hard part, in my opinion, is just the algebra over here. Might be tricky because I don't know, people might not like 2 over e for some reason, but yeah, just got to be careful there with the algebra. And then yeah, you can see usually at these endpoints, it simplifies to a pretty nice power series that we can pretty easily determine the convergence of. So that's the sign as to whether you probably did it right or not. Okay, all right. Hopefully this was a good practice problem if you needed it. If hopefully my explanations helped as well. Please give this video a like if it helped you in any way. And there's a couple more radius of convergence problems I'll be posting soon. So please subscribe if you want to get notified for those. Hopefully see those videos. Bye.